So this lesson that we're going to talk about today is how to solve a quadratic by square rooting. This is our first method of solving quadratics. We are going to talk about several different ones. And this one is probably the simplest, but there's quite a bit involved in how to solve this way, okay? So we're going to kind of work through this. Our goals for today are to be able to solve quadratic functions using the square rooting method and to talk about when this is appropriate. Like I said, there's going to be four different methods we're going to talk about, and different methods work in different situations. We're going to talk about how to know if this is the right way to solve. Looking at this first one here, when we are solving, we want to make sure that we are considering any answers there are. So normally I would say, okay, x squared equals 25. I'm just going to square root both sides, and that means that I get x equals 5. However, remember that there are actually two numbers that can be squared to get 25. Positive 5 squared is 25, but negative 5 squared is also 25. So when you are solving, make sure that you're including both answers using that plus or minus sign. So when I come over here and I talk about square rooting negative 16, this goes back to what we just talked about with complex numbers. So remember that first of all, you have that I, and now I'm square rooting a positive 16. Well, 16 has two square roots, positive 4 and negative 4. So I'm going to say that x equals plus or minus 4i. Okay? Remember that when you are square rooting, you always have two answers. Every quadratic that we solve is going to have two answers. Often, we will use that plus or minus sign to describe those answers. Now, when you're solving, make sure that you do not square root until that x squared term is by itself. So looking at this first one, I need to do something with this 2 to get it away from the x squared. I'm going to divide both sides by 2, and then that gets me x squared equals 64. Now that I've got my x squared alone, I can square root both sides, and I get plus or minus 8. The square root of 64 is plus or minus 8. Over here on this one on the right here, I'm going to have to subtract 14 from both sides so that I can get the x squared alone. When I do that, I end up with x squared equals negative 49. I'm going to square root both sides here, which means that x is, remember when I'm square rooting negative, I need an I in my answer, and the square root of 49 is 7. So I'm going to say plus or minus 7i. It's really important when you are square rooting that you take both answers with that plus or minus. Also, when you're square rooting a negative number, don't forget that you need an I in your answer. When you're square rooting and it's not an integer, so far we've done 64, which is 8. We've done square root of 49, which is 7. The square root of 25 is 5. What about when we get something like the square root of 17? That's not an integer. We want to leave our answer in radical form. We do want to simplify it if possible. And don't forget that if the radical is negative, we still need an I there. Okay, so we're going to work through a couple of these. I still need to get that x squared by itself. So I'm going to start by subtracting 5 from both sides here. And 41 minus 5 is 36. Then I'm going to divide both sides by 3. And I get x squared equals 12. I'm going to square root both sides. But this is kind of what we talked about where 12 doesn't have an integer square root. If I put that in my calculator, I get a decimal, 3 point whatever on forever. So instead, I'm just going to leave this as plus or minus, and then I'm going to simplify 12 if I can. So I'm going to make a factor tree real quick. Remember when I make my factor tree, I'm looking for pairs, and I have a pair of 2's. So that's going to come outside my radical. My leftover 3 is going to be inside. So x equals plus or minus 2 square root of 3. So I'm leaving it in radical form because that's exact, but I am simplifying my radical because I can pull that pair of 2's out, okay? So you're leaving it in radical form, but don't forget to simplify or put an I if there's a negative in order to keep that radical as exact and as simple as possible. Now looking at this one looks a little bit different, but I'm still going to do the same thing. I'm going to divide by 2, and this time I'm getting my squared quantity by itself. Negative 48 divided by 2 is negative 24. Now I'm going to square root. When I square root this quantity squared, basically they're canceling each other out, and I'm just left with what's in the parentheses, which is x minus 1. Okay, this is the same thing when you square root x squared, it's just x. It's the same idea. A square root undoes a square and leaves whatever was there alone. Now on the other side, I know I'm going to have a plus or minus, and I know I'm going to have an I because I've got a negative, and I'm going to make a quick factor tree here and see if 24 can be simplified. Here's a little spoiler alert. I know it can be simplified because I wrote the problem. So I know I've got a pair of 2's here. Those are going to come outside with the I. Then my leftover 3 and 2, which is 6, is going to go inside. Now I still have one more step because I haven't gotten the x by itself yet. So I need to do something with this 1. I need to add it to the other side. So what I'm going to do is I'm going to add it, and you can't see me, but I'm air quoting, add it to the other side because I'm not really combining anything. I'm just moving it, okay? So now I have 1 plus or minus 2i square root of 6. So all I really did was move that 1 to the other side and change its sign, okay? I'm not actually adding it to anything. You cannot combine 1 and 2i. That's not possible. Remember, we talked about complex numbers. Your real part and your imaginary part cannot be combined. So we're just going to leave our answer like this. Okay, welcome to the world of quadratics. We often have complicated, crazy looking answers that include i's and plus or minuses and a couple different terms. This is one kind of ugly, complex number here, okay? Let's try one more. This time I'm going to add 8 to the other side. Again, I'm trying to get this squared by itself. So 15 plus 8 is 23. Now I'm going to square root both sides. And again, the squared and the square root just cancel, leaving me with x plus 5. 23 doesn't have a square root. 23 is also prime, so it can't be simplified. So I'm just going to leave this as plus or minus the square root of 23. Okay? Now, I got to get that 5 away from the x to the other side. So I'm going to do the opposite. Since I'm adding it to x, I'm going to subtract it to the other side. And I get negative 5 plus or minus the square root of 23. That is my final answer. I hope this is starting to click a little bit, just that you can see how we are square rooting, but we have to get the squared piece, whether it's x or the quantity, by itself in order to square root. And then we kind of work through the steps of solving. A lot of times when we're doing quadratics, we are going to get these sort of strange looking answers that have radicals and plus or minuses in them, even i's, okay? So it looks weird, but you did it correctly. So don't worry about that. As always, this has been another production of Conalonzo Inc., bringing you lots of math information. If you ever need anything, please let us know. We are more than happy to help.